Hi, welcome to this Corbettmaths video on increasing or decreasing functions. In this video, we're going to look at what an increasing function is, we're going to have a look at what a decreasing function is, and we're going to look at how to answer some questions to find when a function may be increasing or decreasing. So first of all, what is an increasing function? An increasing function is a function which is always going upwards, and what I mean by that is as the values of x are increasing, the values for y are increasing. So here we've got an increasing function, and the gradient of the tangent to this curve, the gradient of the tangent to this curve will always be positive. So the gradient is always positive for this function. So that means that dy by dx will always be positive for an increasing function. A decreasing function is a function which is going downwards. So as the values for x are increasing, the values for y are decreasing. And the gradient of the tangents will always be negative. So dy by dx will always be negative for a decreasing function. Some functions are increasing or decreasing for different values of x. So if you think of a quadratic, obviously just something like that, you'll see it will be decreasing and then it will then become an increasing function. So here we've got a cubic, and we can tell this because we've got the maximum point here and the minimum point here. And for some values of x, this cubic is increasing. So it's increasing here, increasing until you get to here. So for all these values of x, dy by dx is positive. Then the function starts to decrease, and it decreases all the way down to here. So for these values of x, this is a decreasing function. And then for all the rest of the values of x, so all these values of x, the gradient is positive, so it's increasing again. So this function, this cubic, is increasing, then decreasing, and then increasing. Okay, so our first example says find the range of values of x for which the function f of x equals 5 plus 12x minus 2x squared is increasing. Now we're going to solve this question using two different approaches. The first approach is just considering what the function looks like and then working out the values of x for whenever the function is increasing. So looking at the graph and working that out. And the second approach is just by considering that dy by dx is positive, that the gradient is positive for an increasing function. So we'll just differentiate it and solve that inequality. So first of all, let's consider what the function looks like. So it's 5 plus 12x minus 2x squared. So it's a negative x squared. So it's going to be an n-shaped parabola. So it's a quadratic, but it's a negative one. So it's going to look something like that. And we know that this function is increasing up until the stationary point. And then after the stationary point, it'll be decreasing. So we know that all the values of x left off the stationary point will give us an increasing function. So let's find the coordinates of this stationary point. So we know that at a stationary point, the gradient is equal to 0. So dy by dx is equal to, and differentiating this, well, differentiating 5 is 0, differentiating 12x would be 12, and differentiating minus 2x squared, we're bringing the 2 down, would be minus 4x, and reducing the power by 1 will just be 1. Now we know that's equal to 0, so 0 equals 12 minus 4x, and adding 4x to both sides will give us 4x equals 12. Dividing by 4 will give us x equals 3. So at the stationary point, the x coordinate is equal to 3. Now, we don't actually need to know what the y coordinate is because we're only interested in the values of x for which the function is increasing. And we can already tell now that every x value less than 3 would give you an increasing function. I do know that the y coordinate is 23, so I'm just going to write that in anyway. Okay, but as I said, we're trying to find the values for x for which the function is increasing. Now, everywhere to the left of the stationary, the gradient is positive. It's increasing. So x is less than 3 would be our answer. All the values of x less than 3 would give us an increasing function. Anything bigger than 3 would be a decreasing function. Okay. Our second approach is just by considering the dy by dx. We know that it's increasing, so we can say that dy by dx is positive. It's bigger than 0. So if we want to find this, what we're going to do is we're just going to differentiate, which we've done. Dy by dx is equal to 12 minus 4x. And for an increasing function, it's going to be bigger than 0. Now we can just solve this inequality. So adding 4x to both sides would give you 12 is bigger than 4x. Dividing both sides by 4 would give you 3 is bigger than x. And just writing that the other way around would be x is smaller than 3. And that's it. As you can see, both approaches give you the same answer. Some students prefer to use this approach, just considering what the graph looks like and then working out when it's increasing. Some students just like using the fact that if it's an increasing function, dy by dx is positive, and then solving that inequality. Okay, let's have a look at a function which is a bit more complicated than a quadratic, so a cubic. And so here we've got our cubic, and the question says, find the range of values of x for which the function, f of x equals x cubed plus 4x squared minus 3x plus 1 is decreasing. So this time we want to find when this function is decreasing. Again, we're going to use our approach where we consider what the graph looks like, the function looks like, and we'll solve it that way. And then we'll use our second approach by just knowing that for a decreasing function, dy by dx would be less than 0. Okay, so our first approach is considering what the function looks like. So we have got a cubic, so it's going to look, and it's an x cubed, a positive one, so it's going to go up and then down and then up again, something like that. And I'm just going to put in the axes, something like that. And we're trying to find when the function is decreasing. So let's have a look at this function. It's increasing, 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 increasing to the first stationary point. And then it's decreasing, decreasing, decreasing to the second stationary point, and then increasing again. So it's this section that we're interested in, and it would be the values for x between the two stationary points, because it's decreasing from the first stationary point down to the second stationary point. Okay, so we need to find the coordinates of these two stationary points. So we know that for dy by dx will equal 0 at a stationary point. So let's differentiate. So that would be 3, differentiating for x cubed would be 3x squared, plus differentiating 4x squared, we'll bring the power down, that'd be 8x, and then to the power of 1, so we'll just write 8x. And differentiating minus 3x would be minus 3, and differentiating 0 would be, or differentiating 1 would be 0. So dy by dx is equal to 3x squared plus 8x minus 3. Now at these stationary points, we know that the gradient is equal to 0 here and here. So we're going to put that's equal to 0. So 0 equals 3x squared plus 8x minus 3. So let's factorize this and find the two values for x for whenever the gradient is equal to 0. So 0 equals, I'm factorizing, 3x in one bracket and x in another. Now we want the two numbers to times together to be negative 3, so, and we want, whenever we expand it, to get an 8x in the middle, a positive 8x. So I'm going to put a plus 3 over there, so that will give me 9x, and then a minus 1 here. And let's just test that. So 3x times x is 3x squared, 3x times 3 is 9x, minus 1 times x is minus x, that'll give me the 8x that we need, and minus 1 times 3 is our minus 3, which is what we wanted. So let's find our values for x here. So x equals, here we are going to get 1/3, and here we're going to get x is equal to minus 3. So that means that if we go back to our graph of our function, our first turning point will be at negative 3, and our second turning point will be at 1/3. So we're trying to find when this function is decreasing. So it's for all the values of x in between minus 3 and 1/3. So let's write that down. So that x is any value of x that is bigger than negative 3 but less than 1/3 will be a decreasing, or will give us a decreasing function. Okay, so that's by considering those key points, those stationary points. The second approach is just by using the knowledge that if it's a decreasing function, that dy by dx is less than 0. So dy by dx, well, we've differentiated already, so dy by dx is equal to 3x squared plus 8x minus 3, and we want to find when that is less than 0. So we're going to write that down. 3x squared plus 8x minus 3 is less than 0. Now this is a quadratic inequality. To solve that, we're going to sketch the quadratic. Our critical values, our points would be, if we factorize this and solved it, well, we've already done that already, so factorizing it, 3x minus 1 and x plus 3. So that would be here at negative 3 and here at 1/3. And if we sketch that, it would be our quadratic, it would look something like that. And we're trying to find when it's going to be less than 0. So that will be in between negative 3 and 1/3. So x will be less than 1/3 but bigger than negative 3. And as you can see, both approaches give you the same answer. And that's it. So for increasing and decreasing functions, obviously if a function is increasing, dy by dx will be bigger than 0. If it's decreasing, dy by dx will be less than 0. Some students prefer to solve this by considering what the graph or the function looks like and finding the stationary points and then using their common sense to work out when it's increasing or decreasing. And some students prefer to find just to get dy by dx and write down it's bigger than 0 and solve that inequality, or less than 0 and solve that inequality. And that's it. And sometimes you'll get a quadratic and just remember how to solve quadratic inequalities. That's it.